So today we're focusing on these things called further proofs. So it's still mainly using the 3 steps of mathematical induction, which we've been focusing on already, but it's just, how to say, there's kind of more problem solving involved. So there's a lot of, I guess, abstract thinking in these proofs. So yeah, the first example I'm going to show you is this Tower of Hanoi, and you guys have had a go at this link now. So could you see any patterns emerging as you did went from, what was the minimum in the link, 3 to 4 to 5? Did you see any patterns? On the most right, and then the one underneath that there. So there's mirrored moves. At least, yeah, you said in this one. So unstacking them, stacking those two, moving. I noticed moving the bottom one is what you want to aim for, obviously. Moving the very bottom one to the right before you start stacking. Then the second most bottom, etc. So that's just the first one. If you look at the first example, the second part of it, it wants you to do a proof. In these further proofs, you've got to look for patterns. Okay? So I'll show you what I mean. Let's first look at the pattern of this. So if there was one block, how many moves would it take? 1. If there was 2 blocks, one, 2, 3. If there was 3 blocks, how many? 7. If there's 4 blocks, if there's 5 blocks, 31. If there's 6 blocks, 63. Is there any geometric or arithmetic pattern to that? Can anyone see? Times that by 2 plus 1, yep. Can you get it in terms of an n? It's an indice, by the way. So the difference between this is 2. Difference between that is 4. Try and do it with just n. No mn in here. So this tells you that it's going up in an indice or power of 2. So the first one, 2 to the power 1 minus 1. The second one would be 2 to the power of 2 minus 1. Now that's quite a difficult skill to see that. Okay, so if that's the rule, what's the first step for proof by induction? Yep. Now we already know it's going to work because, well, we pretty much already did that, but this is like the formal way now. So it's true for n equals 1. Next step, step 2, let n equal k. So we assume true. Yep. Where n is what? I probably should say k is an element of positive integers. Alright, let n equal k plus 1. Third step, always the tricky step. Any thoughts? So if this tells us the number of moves for the number of, so m is the number of moves, k is the number, or n is the number of wood, blocks, I guess what we're going to get is this, but it's how do we get to that? Any thoughts? How many moves does it take to get 2 blocks? Just 2 blocks? 3, right? So 3 to get 2 blocks, plus 1 move to get the base block, plus another 3 to get the 2 blocks back. That's for 3 blocks. 1, 2, 3. 1 move to get the base block, and then 3 moves to get that block. So there's always this symmetry. It's the previous amount of blocks moves plus 1 plus the previous amount of blocks moves. So the amount of 2 blocks moves plus 1 plus the amount of 2 blocks moves. mk plus 1 is 2k minus 1 plus 1 move, that's the base block, or the extra block, plus 2k minus 1. So if you simplify this, you have 2 times 2k minus 1 plus 1 minus 1, left with 2k plus 1 minus 1. Now obviously I didn't write the words in case you're wondering about communication, but quite a different proof, hey? It's a bit abstract compared to what you're used to.